Okay, now we're going to look at question 1.3. So there's the question. It says the roots of the equation f of x equals 0 are x equals to 4 plus or minus the root of 16 minus 4m, all multiplied by minus m plus 5, and then the whole thing is over 2m. Okay, it says determine the values of m for which the roots will be non-real. Okay, so remember, for something to be non-real, it means that it's mathematically not possible. Okay, so if we look at this expression here, how would these roots be non-real? Well, let's take a square root of something, right? What is the square root of something? Let's say I say the square root of x squared. That's x, right? Because I have to take x times x to get to x squared. Okay, so you can see I multiplied the same thing twice to get to x squared. Okay, now think about this. Is it possible to multiply two numbers and get a negative answer? Okay, let's say for example negative x. The answer is it's not possible. Okay, because if we take two positive numbers, let's say x and x, I'll get to x squared, right? Positive x squared. Okay, and if I take minus x times minus x, I'll also get to x squared, right? Because negative times a negative is a positive. Okay, so it's impossible to multiply the same number twice and have it be negative. So that means that for this to be non-real, whatever is under this bracket has to be less than 0, meaning that it's negative, and that will make it non-real. Okay, so let's say 16 minus 4m times m plus 5. This here has to be less than 0. Okay, so now it's a simple case of just solving for m. So let's multiply all of this out. Okay, let's rearrange this so that it goes like that, and let's equate it to 0. Okay, because much like the other question, we're going to find the critical values first. Okay, so I can use factors here again to solve for this here. Okay, but before I even do that, let's first make this a bit simpler. Let's say m squared minus 5m plus 4. Okay, and why did we do that? We just divided everything by 4. Okay, just to make it a bit simpler. Right, now again, we need to find two numbers that when you add them together, you get to minus 5, and when you multiply them together, you get to 4. Okay, and what two numbers are that? Well, let's think. Let's try minus 4m minus 1m, right? Now if I take minus 4 minus 1, I get minus 5. And if I take minus 4 times minus 1, I get 4. So that means that works because I get minus 5 when I add them and I get 4 when I multiply them. Okay. So now it's just a case of factorizing everything and then taking out the common factor and then equating them both to 0. So m equals 4 or m equals 1. Now again, let's look at this here. What is this? This is a upwards facing parabola. Okay, it's a concave up parabola, right? Because I have a positive coefficient of m squared. Okay, let's drop in our x-axis. And again, where is it equal to 0? When we are at the x-intercept, right? So this is at 1, this is at 4. And if we look at the question again, we're looking for when this is less than 0. So when is the graph less than 0? Well, it's less than 0 when it's in this range here, right? When it's between 1 and 4. So we can say that m has to be greater than 1 but less than 4. And that's our answer. Okay. Okay, let's look at the next question, 1.4. it says show that the maximum value of the root of minus x squared plus 4x plus 12 is 4. Okay, so the easiest way to do this is to look at this and get rid of the square root. Okay, so that's instead of saying when is this thing, or let's instead of proving that the maximum of this is 4, let's prove that the maximum of minus x squared plus 4x plus 12, so I just squared this whole thing, is 16. So 4 squared. Okay, so that's a bit easier to do because if you look at this now, this is just literally a downwards facing parabola. Okay, look at it. If we have a negative coefficient of x squared, that means it faces down, so there is a maximum value, right? Upwards facing parabola, so let's just use this as an example. This upwards facing parabola here will have a minimum value, okay, and a downwards facing one will have a maximum value. Okay, so how do we find the maximum value of a downwards facing parabola? Well, it's at the turning point, right? Because remember, if you go from here, if you start this way and you move up, you're going to increase to a certain point. That's the height. And then from there, it keeps going down. So at the turning point is the maximum. Okay. And how do we find the turning point of a parabola? Well, there's a few ways. Let's just use this way here. So the turning point, the x value of the turning point equals to minus b over 2a. Okay. So minus b in this case will be minus 4 over 2a. So 2 times minus 1, right? And the answer to that is 2. Okay. So the x value of this turning point here, remember this turning point is an x and a y value. So that x value is 2. And now we just have to solve for the y value to get the maximum point. So I'll take this 2. And now it's very much like a functions question. I'm going to take this 2 and I'm going to substitute it into that equation. Okay, so I'm going to say minus 2 squared, so y equals to plus 4 times 2 plus 12. Okay, and if I evaluate that, I get minus 4 plus 8 plus 12, and that gives us 16. Okay, so we prove now that so we can say, therefore, the max value of minus x squared plus 4x plus 12 is 16. Therefore, the max value of the root of minus x squared plus 4x plus 12 is the square root of 16, so 4. Okay, and that proves what we were asked to show, right? We were asked to show that the maximum value of that is 4, and we've done that, so that's the correct answer then.